Hello dear students, in this video we would understand division algorithm for polynomials, a topic from class 10, one of the most important topics. Division algorithm for polynomials states that if px and gx are any two polynomials such that gx should not be equal to 0, then we can find polynomials qx and rx such that, now what's that condition? The statement, according to the statement, then p of x can be written as gx into q of x plus rx, where this rx remainder can be either 0 or the condition where we would stop. At times remainder may not always become 0. Then we would see if degree of remainder has to be less than degree of divisor. So this is nothing but what we had been doing till now. We know this is dividend. When you divide any polynomial by another polynomial, which is called divisor, we get something in the quotient and it may leave a remainder as well. So this is how you would write it. P of x, it's divided by g of x. You get something in the quotient that's represented by q of x. After division is over, something which remains here, it may be 0, it may not be. So that would be your remainder. Now we are taking up questions from your textbook. This is exercise 2.3. Question number 2 says, check whether the first polynomial is a factor of second polynomial by dividing second polynomial by first. So this can be labeled as p of x. This is our polynomial for which would be taken as a dividend. This is g of x, which is divisor. So let's divide and check whether it's a factor or not. X raised to power 5 minus 4x cube plus x square plus 3 times x plus 1. This p of x is written inside and we are going to divide it by x cube minus 3x plus 1. Remember students, whenever we are talking about division of polynomials, our focus should always be on the first term. Over here the first term is x raised to power 5 and in the divisor it is x cube. So you just divide both the terms, you will get to know that what would be the first term in the quotient, because we want to simply eliminate the very first term and then step by step we would move and reach out to the last one. So x raised to power 5 when divided by x cube is x square. So clearly we would be taking x square as first term in the quotient. Now, what is x cube into x square? We know it is x raised to power 5 minus 3 times x into x square. Minus 3 times x into x square would be what? Minus 3 times x cube. So, write the term below this. This is minus 3x cube. Then comes 1 multiplied by x square. So, this would be no doubt x square. Then, in journal, whenever there is a division, over here we go for subtraction. So, subtraction of polynomials, we would have a change of sign. Look at the terms. There are 3 terms. These 3 terms have got, this is positive, this would become negative. Positive, negative would become positive and this positive would become negative. And then this horizontal line comes. Now your focus should be on the topmost term, and if you are looking at this term, the sign for this term would be taken the changed one, okay? So x cube, x raised to power 5 positive, x raised to power 5 negative, this eliminates. Minus 4 plus 3. Minus 4x cube plus 3x cube would be what? X cube comes as such. This is nothing but minus 4 added to 3, which is minus 1. So this is minus 1x cube or just minus x cube. X square positive, x square negative, even this eliminates. Now bring the remaining terms down. The remaining terms are plus 3x and plus 1. Look at the first term. This is x cube with negative. This is x cube with positive. So what should I do? Minus x cube when divided by x cube, first term and first term, this is minus 1. So what we would require in the quotient, it's minus 1. So minus 1 into x cube would be minus x cube. Minus 3 times x, look at this, minus 3 times x, minus 3 times x into minus 1 would be positive 3x. So this becomes positive 3x. Then minus 1 and plus 1 would become minus 1. Change the signs. This is positive. This becomes negative. This becomes positive. Now observe the terms carefully. Minus x cube plus x cube eliminates. Positive 3x, negative 3x eliminates. Plus 1 and plus 1 is 2. So remainder is 2. There is a quotient. Quotient is x square minus 1. Remainder is 2. And kids, if you remember last year in factor theorem, we did the same thing. As remainder is not equal to 0, because remainder should have been 0, but over here it's not 0, that implies gx is not factor of p of x. So we divided this with x cube minus 3x plus 1 because of this remainder, because this remainder is not 0, that's why it's not factor of given polynomial. Now let's pick up the most important question, which is obtain all other zeros of this polynomial if two of its zeros are given as root 5 by 3 and minus root 5 by 3. In this question, let's first of all label this given polynomial as p of x. So here p of x is 3x raised to power 4 plus 6x cube minus 2x square minus 10 times x minus 5. We know if these are two zeros, that implies zeros can be labeled as alpha, beta, but since we are talking about division of polynomial, so this indicates one value of x would be root 5 by 3 and another value of x will be minus root 5 by 3. And if again I'm talking about the reference to the previous year's concept, factor theorem, if I say x which is root 5 by 3 is its 0, that implies x minus root 5 by root 3 is factor. Okay, and if this is factor, this would also be factor, and if these two are factors, their product would also be factor. So this is how it becomes. If x equals to 2 is a 0 of any polynomial, that means x minus 2 is factor of polynomial, right? If x equals to minus 1 is a factor, is a 0, that implies x minus of minus 1, which becomes x plus 1, is factor of polynomial. Same is the concept here. If x, which is root 5 by 3, is 0, it means x minus of root 5 by root 3 would be the factor of this. If x which is equal to minus root 5 by 3 is its 0, it means x minus of minus would become plus. So this is x plus root 5 by 3 would be its 0. Now since these are zeros, this indicates they must be resulting and giving us 0 because their product has to be 0. Their product would be 0, and if their product is 0, on simplification, what is this? This is a minus b, a plus b. It becomes a square minus b square, and this is 0. And if this a square minus b square is 0, further if you simplify, this becomes x square minus 5 by 3 is 0, or it is 3x square minus 5 by 3 equals to 0. What can we further do? It can be written as 3x square minus 5 equals to 0, because this 3 which was in the denominator, when goes there it becomes 0. From here we know that this would be p of x, and gx is obtained from these two zeros, and this is our gx. Now next what we have to do? We would divide this polynomial by g of x, which is 3x square minus 5, and on division whatever is obtained in the quotient will give you 2 more zeros. Now why do I say 2 more zeros? Since it is a biquadratic polynomial, 2 zeros are already there. These were given. 2 more would be found, because biquadratic when divided by a quadratic would give you a quadratic polynomial in the quotient. So that quotient would be further broken down by splitting middle term, and we will get 2 more zeros from there. Let's see how do we do it. Now watch this carefully. We are dividing the given polynomial by 3x square minus 5. The first term, which is 3x raised to power 4, this is 3x square. So what should I write as first term in the quotient? This must be x square, because we know 3x raised to power 4 when divided by 3x square gives you x square. So x square comes as first term in the quotient. 3x square into x square. Let's now write these terms. This is 3x4. This would be minus 5 times x square. Where should I write it? Below the like term. So minus 5 times x square is over here. Yes. Now change of sign. This would become minus. This would become plus. 3x raised to power 4. Positive negative eliminates. Bring this term. Let's go in a sequence. This term, which is 6x cube, comes as such. Minus 2 plus 5 would be positive 3, and this x square comes as such. Bring other terms also down, which is minus 10x and minus 5. Move to the first term again. This is 6x cube and this is 3x square. This would be 2x, because x square this x cube divided by x square would give you 2x. So this would be our second term of quotient. So this becomes positive 2x. We know undoubtedly first term has to eliminate. This would be 6x cube minus 5 into 2x would be minus 10x. This is minus, this would become plus, and this eliminates. Write them in the sequence again. 3x square, this eliminates. Minus 10x plus 10x, this also finishes off, and minus 5. So we have now just two terms, 3x square minus 5. This is also 3x square minus 5. So plus 1 would be the last term of the quotient, and this would become 3x square minus 5. Signs will change. This finishes and 0. There is nothing in the remainder. So remainder is found to be 0. Remainder had to be 0 because we divided it by its two zeros, right? Now what would be the next step? Now we need to deal with this polynomial. We know this px can be written as gx into qx plus rx. If I talk about verification also, this polynomial, how is it obtained? It is product of gx, we divided it by 3x square minus 5, and qx, which is x square plus 2 times x plus 1, and plus remainder. What's the remainder? The remainder is 0. Our next step would be, this would remain as such. We are finding other zeros, so let's just focus on this now, because we know how did we get this factor. ये कहाँ से आया है? It has been obtained from the two zeros which were given, root 5 by 3 and minus root 5 by 3. These two zeros were given. So now let's find out zeros of this. For zeros of x square plus 2x plus 1, what should we do? Equate it to 0. Alright, and when you equate it to 0, this is nothing but it's a square plus b square plus 2ab, or I can say it is x plus 1 whole square equal to 0. Now kids, listen, there are two ways of doing it. You can either split the middle term, product we need 1, sum we need 2, it is 1 into 1 which is 1 and 1 plus 1 which is 2. Another way is the way I have done, applying the identity. It's a square plus b square plus 2ab. So it's x plus 1 whole square. So this set has got two repeat roots. X plus 1 whole square is 0. That means x plus 1, either this x plus 1 is 0 or another x plus 1 is 0. So x becomes minus 1 or x can be minus 1. So what are the four zeros? 2 I have already written, plus minus root 5 by 3, another is minus 1 and minus 1. So these are four zeros for question number 3, which was talking about, which wanted us to obtain all other zeros of the polynomial. I am sure this must be clear to everybody. Question 5 of exercise 2.3 demands examples for px, gx, qx, rx which should satisfy this relation. I am talking about the first part, which says degree of px and degree of qx should be same. Now we know it's only possible if we divide, if this divisor is a constant term. Okay, this can be possible because px would be divided by gx, and degree of polynomial, suppose let's pick the polynomial. Let me take px as twice of x square minus 2x plus 14, and gx would be a constant, because if you divide this polynomial, if this polynomial is divided by a constant, qx would have the same degree. Divide, when you check the terms, karo divide, this would become x square, this is 1 and this is 1x, this is plus 7. qx px, degree check karo, degree is 2, this also has got degree 2. What else was required? That's it. And then what about remainder? Would it leave a remainder? No. But our focus was to simply see that degree of px, which is 2, and degree of qx is now same. And when could it be possible? When we divided this by a constant polynomial. We took a constant number itself, 2. 2 is also a polynomial because it can be written as 2 times 1 or 2 into x raised to power 0. So what is the degree of this? Degree is 0. Constant polynomial would have 0 degree and 0 polynomial would have a infinite degree. I hope you know, last year we have done this. Degree would be infinite. So first I am sure is clear. Second part from the same question says, look for examples of these when degree of qx and degree of rx, quotient as well as remainder, has got same degree. So kids, this is only possible when degree of qx and r of x should be less than p of x and g of x. Their degree should be less than these two. Let's take an example. If suppose p of x is x cube plus x square plus x plus 1, what's the degree? Degree for px is 3. Gx. Now I am taking gx as x square minus 1. Degree is 2. When you divide these two, you have to actually divide and see. Qx would be x plus 1, okay, and rx would be 2x plus 2. So look at this. Now degree of qx, what is it? 1. Degree of rx is also 1, and their degree is less than px as well as gx. I am sure you would be able to divide and check this yourself.